Hi everyone, I am Gabriel Waltman and I am learning Java and your ecosystem. For today, I have studied data structure and for this topic I make a different way. I make a diagram. Let's show that. This diagram has a lot of topics like hippie, arrays, cook, uh, quicks, and stacks. So in each topic, I will pass I the things that I have learned and how I understand each topic from data structure. Alright, let's start with array. So array can't have mixed type, needs have a fixed size and can't allocate more space. To create this collection of items, this is storage consecutively for include a new item or update that is always, always will find a new space on the memory than all I mean where the language can storage the current array more the new items. For example, to store this, sorry, to update, this is will search for a new space in memory that it can allocate all bytes sequentially from the array. In JavaScript case, we have then 29 and 11. We create the array, include a new item, and to include a new item, we can't allocate here. We only can allocate here because if I try include 20 on the next byte, it block from the representation is a byte. This will block because that is already allocated with other data. Alright, let's get more space hiding the shapes. Alright, this is better. Alright, to store a new array that will get the max of bytes to a single item from the array. For each item, JavaScript is allocated the max byte length from all items. For example, we have an array with the item then BMW and true. The biggest item is BMW. It needs to allocate 3 bytes to the item. So the first and the third element also will allocate 3 bytes. In array, this is how the array of the JavaScript works, but primarily it can't have a mixed types like that. This is a C++ code where we can allocate only one type of data like integer, like boolean or char. We can't allocate more space. JavaScript only create a new space. Sorry, I mean the JavaScript create only a new array, nor a new space. The space is the memory. Memory is fixed size, alright? To access an item with the array, we have a complexity O1 because we already have the index of the item. If you need 11, we use the index 2, and if we need to access the first element, we will use the index 0, so it will only execute one single. Alright, insert is different because it will insert a new element and it will rewrite all the array in a new local, in a new memory space. To delete is the same step, because if you want to delete the 11, 1 will place on the 11 place. Alright, update is the same case, insert is the same case, and so, and to array is that. So let's see the next topic. Next topic is quicks like that, because we have a case as apple and value as 5, and to find these values, let's say you have a supermarket system and you need to find the price of the kiwi, so you will passing in a hashing function that take the input and give back the hash code or index in array. For example, kiwi has the kiwi, it will return the 4 as index, and will find the value on the array where the index is 4. Alright, to handle collisions, because you can allocate in the same index more of one item, so you can place, for example, mango and index 5 where apple with value 6 already exists. Alright, so if you search for mango, this you find first 5, and after inside this simple array we'll find the mango. Alright, and the next topic is quick is the 5th because it's first in, so one value was the first element to join on the list, and last in, so it is the last left from the quick. Alright, and in quick we have a linear collection of items, inserting, deleting in a particular order. Pick will get the item if you remove the item. Push will include the new item. In pop will get the item and remove the list. Each new item is added on top of a previously added item. So you can include the 11 value. This will use it and get buffer the after the 6th value. Alright, so next topic is like ASO select is to a few, first out, last in. So in this example we have John Doe as first element and the last element Baby Doe. The first element that you get or removed will be John Doe and the last will be Baby Doe. Alright? This is like a paper select, so you can have a paper after other, and to remove you get the top element and remove, and after remove to until you zerate the array. Alright? Linked list are a linear collection of items. First element is the head, so we have the head. The last element is the tail, and we can link the one node to other node. So let's get the O as an example. That is a node. The prev of this example is the R as a prev node, and the next node is the A. Alright, we have to a double linked list where the node will indicate the prev element and the next element, the next node. Alright, this is a better word to use in this case. On the tail, the next for default is null, and head, the prev element is null, but you can use a circular linked list where the last you point to the first and the first can point to the last as prev. Alright, to delete will be a complex O1 because you only create a new node between two nodes, and to update this is a ON because you need primarily find the element like the A, and after this need update the element and update the next and after. Insert is the sum O1 because you can only insert between two elements on the first on the last, and two accesses is ON2 because you need to pass an each element to find your value that you is searching. Alright, each element point to the next element in the memory. Alright, accept different types of the data. So to allocate a lot of different types of data, the linked list is better. Alright, each node has the data and the next node address, and last element has address as full. Alright, let's next to the next topic. Alright, and next topic is tree. The tree is funny because this really looks like a branch, but has some difference. This has node and not fruits. Has edges, that's this line is. Has lift node, like it is that the each is the last nodes on the branch. Has the root node is the top of the tree, and the parent node, let's make 31 as example, so the parent node is 1. Alright, this is the node height. We have 2 elements, and the height of the tree, and the tree is 3 because we have 1 line, 2 line, 3 lines. Alright, in a tree we have a variant binary tree, and inside the binary tree we can use a complete binary tree where all levels of the tree is filled except the last level. It may be filled from the last side. Sorry, maybe it was writing strong, but I will fix after I put the link of this file below on the description. Alright, nodes are sorted, and full binary tree has node can have 2 or 2 elements. The maximum numbers of children a node can have is 2. Binary search can falling. Alright, is grateful is great then parent node, or left node is one more than parent node. Right nodes can be biggest than parent node. All left nodes can be less than parent node. The hierarchical about the trees has the parent node, left nodes can have length, root node have edges, and the tree has the height. Alright, in a tree we can categorize the tree in a balanced tree that has all log n complexity, equal nodes numbers from the left and right side. So that's example is a balanced tree, and we have two unbalanced tree, all and where it inserting result in an increase of the tree height. Alright, so we can modify this example. Let's make this, and this like the tree. Other elements will remove it, so we have unbalanced because all the elements are in a single side. Alright, to find the element in this, you need to pass in each element, but you need to find it in a balanced is more efficiently because it is greater than we will find it here and not here. Alright, we'll ignore this side and we'll find it only here and only here and only here. So this is a is a O log n. Alright, let's view full screen again and let's see. And unbalanced to traveling, we can follow a post order, left, right, root, pre-order, root, left and right, and in order, left, root and right. So let's see the next topic, graphics like a web but It has vertices, nodes, tree, data based. We can use indirect graphics, indirectly any direction on any of the edges, can travel to any edges, so we can from the A travel to other any node, alright? Or we can work with directly direction entirely to each of the edge, so to go to the F, start an A, you need falling to B, falling to C, and you can't, apparently, you can't fall into the D because this is starting from D. So to go to the F, you need start at D, and the D you can go to the C or A and F, but you can't go from the A to the F. Alright? In graphic, to represent in a language program, you can use adjacency matrix or adjacent list. In adjacent matrix, we can use to the array or hash map. To adjacent list, you can use a normal array or linked list. Graphic has some terminologies like path. Path can be closed or simple. Closed start node in sum as ending node, and simple nodes are not repeated in the path. Set of the edges that connect a set of nodes. This is a path. Loop a edge that connects a vertex in itself. Degree of nodes, number of edges connects a node to graphic. In degree of edges coming out, degree of edges coming out. Circle graphic are all nodes connected with all nodes, and numbers of edges is equal number of edges connected to the graphics. You can visit any node from any other nodes, so is like this example, right? And complete graphic, each node is connected to every other node with exactly one edge. Oh, correct my last example. Connected graphic is like this example, and this complete graphic where other node is connected with exactly one edge is this like example. Alright, edged graphic, each edge has value if assimilated to it, and simple graphic is having no loop or parallel edges, so this can be a simple graphic. So let's see the last topic, the heap. Heap is a tree based where we categorize in a min heap or max heap. Max heap, to insert a new element, will follow some step from the tree to insert, but keeping sweeping with node is greater parent node. And the min heap will insert but keeping sweeping if node is less parent node, like example, or the value in the parent is greater or equal the value should. So if you want to remove an item like the 99 and 99, you will get the last node and put on the top like 65, move it to the top. If it is not the greatest element grayest node, it will sort the 25 to the top and put the 25 that is here to here. Alright, on the min heap, the value parent is less or equal the value should, like that, where the small value is on the top and the grayer value on below, different of the max heap, where the grayest value is on the top and the mean value is below. Alright, so in the mean we can remove the 5, get the last node 89 and put on top. If it is not sorted, the tree is sorted to organize the tree. So let's see, I finish all. To delete is the sum, so move the last node to the root, comparing bubble down if necessary. Alright, this is all the topics that I am learning about data structure. This is a simple resume. I don't learn in profound, I don't learn deeply, but it's a good start. If you have you won't have a better explanation about this topic, you can access it on the roadmap.s/java and access the topic data structure and access the video. This has a good playlist about each topic using images and illustrations about each type, so this is a better teacher like me, than me. So data structure is a reader topic I learned it, but then I will program my portfolio. I can access gabrielwaltzman.com.br. This will access my portfolio. I want to write using a backend to inform this data, these topics, editing, create a dashboard. So I use Java on the backend, and to data structure I can use a new data type like data structure or type, alright, like Redis. Redis is a quick database to create a cron job, alright. So this is maybe I can use on my portfolio, and I am go again to see how it is really work on the real project. Alright, for today is that. If you have an opinion, a suggestion or a tip, please comment below. Give me a like if you like how I am following my studies. But if you have a tip, don't only to about Java, about English. I am a Brazilian programmer, and I am learning about this language, and I am improving, I think. But you can comment about the comments or make suggestion about the videos, if you as liking that I am using Draw.io, or you prefer other methods to watch these videos, you can comment below. Alright, thank you for watching this video.